Okay, now we design a strip footing. So here the example, design a strip footing for a wall. So strip footing for a brick wall having 30 centimeter thick wall and 3.5 meter height above ground level. The wall carries superimposed load of 120 kN. The soil has a unit weight of 17 kN per meter square and angle of repose of 30 degree. So, and shape bearing capacity of 160 kN per meter square soil bearing capacity. The footing may have cement concrete base. Okay, so footing of cement concrete and its unit weight is 24 kilonewton per meter cube and the modulus of rupture is equal to 520 kilonewton per meter cube and the unit weight of masonry is given 19.5 kilonewton per meter cube. Okay, now analyze the value of example. Okay, so what is the first given data? Right, first given data. So first value, the thickness of wall. So thickness of wall is equal to 30 centimeter. So equal to 0.3 meter and its height is small h 3.5 meter. It is your height of wall. Now your superimposed load means Q. Superimposed load is equal to 120 kilonewton per meter. Okay, this all data is for 1 meter length. Okay, so we design a strip footing for a 1 meter length. Okay, so assume that we design a footing for a 1 meter length. Understood why? Because the superimposed load is given 120 kN per meter. So, and soil unit weight means gamma soil, or you can say gamma S is equal to 17 kilonewton per meter cube and phi angle of repose is 30 degree. Your soil bearing capacity SB C is equal to 160 kilonewton per meter square. Okay, now your footing have a cement concrete base. So gamma CC is equal to 24 kilonewton per meter cube and the masonry. So unit weight of masonry is equal to 19.5 kilonewton per meter cube. Okay, so this is your given data. Now the calculation. So what we do first, so we have imposed data, soil bearing capacity, unit weight of cement concrete, unit weight of soil, okay, and thickness of wall. So first we calculate the total load. Total load is transferred to the soil. Okay, so how we calculate what? So there is a imposed load. Okay, but first we need to find the self weight of wall. So first what we do, we find the self weight of wall. So you know that how we find using that unit weight and its dimension. So using dimension, first we find its volume and then multiply with its unit weight and we get that self weight of wall. So That first one is volume. Okay, so here we have a thickness of wall and height of wall, and length is already assumed, that is 1 meter. So first one is LBH. Okay, volume, length, width equal to 0.3 meter and height is 3.5 meter. So that this is your volume, L into B into H, and then multiply with unit weight of masonry. So unit weight of masonry is 19.5 kilonewton per meter per. So multiply it 19.5. Okay, so 1.3 into 3.5, 0.3 multiply 3.5 into 19.5. So you get 20.47. So this is your weight, kilonewton. Okay, so self weight of wall. Now foundation also have its self weight. So also we find the self weight of foundation, but we didn't know that what is the width and its depth of the foundation. So what we do, so for design we assume that weight of foundation is equal to 10% of total load. Okay, so 10% is total load. So we need first to calculate that total load. So what is total load? So imposed load, superimposed load plus self weight of wall. So what is say superimposed load? So it is 120 kilonewton, and plus that value is 20.47, or you can write 20.5. Okay, for assume that it is 20.5. Okay, so it is 20.5 and total load of 10%. So multiply with 10%. Okay, so 0.1. So calculate once again that 120 plus 20.5. Okay, so the value is 14.05 kilonewton. This is per meter value. Okay, per 1 meter length. It is that self weight of foundation. This is assumed. Now find total load. Total load transfer to soil. Okay, so add all the weight in total load. So what is first one is self weight of wall. So it is 20.5 plus superimposed load, it is 120. Then the assumed foundation weight, it is 14.05. So calculate total weight. It is 20.5 plus 120 plus 14.05. So it is 154. Okay, so 154.55 kilonewton per meter. Okay, so this is the total load transferred to the soil. Understood? 154.55 kilonewton per meter. Now we find that width of footing on the basis of ship bearing capacity. Understood? So next is width of footing. So width of footing is found using that shape bearing capacity of a soil. So there is an equation we discussed in a lecture is width equal to the weight or total load W divided by shape bearing capacity is equal to Q soil. Okay, so it is already in a given that SB shape soil is 160 and that we find total weight. Okay, so the calculation is what is total weight we find in previous lecture, this 154. Okay, so write 154 155 divided by 160. Okay, now we calculate that 154 155 divided by 160, so equal to 0.96. So that is the weight of footing, but it's visible that is equal, this is meter. Now correct it in a round figure, it is 1 meter. Okay, so the B equal to width of footing is 1 meter. Now width is fixed, so that is your width and it is 1 meter. Okay, now the depth of footing. Okay, so for depth of footing, the equation you use Rankine formula is D minimum. This is minimum depth. Okay, this depth we find is a minimum depth. So D minimum is equal to Q. Q is a soil pressure, means okay, what the total load transferred to the soil. Then gamma of soil means soil unit weight. Then 1 minus sin 5 upon 1 plus sin 5 raised to whole square. So you know phi angle of repose. Is it also in a given in example? Okay, Q that we find first, that is 154. Okay, gamma soil, okay, that is at 17 kilonewton per meter cube. It is already given, and angle of repose, it is a 30 degree. It is also in given in example or data. Okay, given data. So write all the value in this equation. So 154.55, then your value 17 kilonewton, then 1 minus sin 30 degree, 1 plus sin 30 degree is to whole square. Okay, now calculate. Okay, so after the calculation, that sum, okay, put the value of sin 30 is equal to 0.5 and whole square. So using multiple and you get that 1.01 value. So write 1 meter is your depth of footing. So now you have a 1 meter depth and 1 meter width of footing, means the box is prepared. Okay, there is a 1 meter depth and 1 meter height. Okay, now in lecture you see that projection is also given. Okay, like this projection. Okay, in a wall foundation. So also you need to find get how height, how many distance are given or how many space are there. Okay, so now calculate this distance, that height of offset and this distance or projection. Okay, so now what we do? Okay, so now you know the depth equal to 1 meter and its width also is equal to 1 meter and thickness of wall is 0.3 meter. Okay, depth, width and thickness of wall. So now just roughly draw the rough sketch of a foundation. Okay, something like this. Okay, this is your 1 meter and this is your 1 meter depth and 1 meter is width. Now from 0.3 meter to 1 meter. Okay, you know the width is increasing from 0.3 meter at a ground level to 1 meter, or you can say 100 centimeter at a base. So based on that, from that center, okay, each side increase 50 centimeter. Got it? Now that projection, this value projection, we fix what is it is a equal to 15 centimeter first for each side. Okay, each side projection we fix. So what we have, so the total width equal to 100 minus this 15. Okay, 15 in both sides means multiply with 2, it is 30 centimeter minus 30, it gives 70 centimeter total. But what each side, so once again divided by 2, it is 35 centimeter each side. Okay, each side. So here 35 centimeter and also here 35 centimeter for a projection, means offset, this offset. Okay, we have 35 centimeter. Understood? And also we reduce this also we minus this 0.3 thickness because it is already there. Okay, this thickness is already achieved. So also from the 70, from 70 we minus 30 centimeter. So it is once again it is 40 centimeter total. Okay, we missed that part. Okay, because this is already included in a 1 meter length. Okay, so what we do first, we do the projection fix the projection is equal to 15 centimeter. So total projection distance or length is equal to 20 centimeter, this both side. Okay, then after what we do, that thickness of wall is also deduct from that total width of footing. So once again 70 minus 30, so it is 40 centimeter, sorry. So now we provide a projection in a 40 meter. So now for each side 40 by 2. Okay, so 20 meter horizontal distance. Okay, 20 meter horizontal distance each side we have provided for a offset. Offset means this. Okay, these are called offset. Okay, so there how many number are offset are there, or the minimum height of offset is provided. But as per standard, the maximum offset in a brick is 5 centimeter. Means के maximum offset in brick masonry is equal to 5 centimeter. Okay, so 5 centimeter is fixed. So the min Okay, now offset is value like this. This is your 5 centimeter maximum provided. Okay, this is your brick. Okay, so this is 19 or this is your 9, or just assume that is 10 or 20. Okay, so height is also 10. Okay, without cutting, but for that, for offset it is 5 meter. Generally we provided it is 5 meter and height is 10 centimeter. Okay, so projection is 10, so height is fixed, but the maximum projection is provided is equal to 5 centimeter in a brick masonry. So calculate the minimum height of each offset. So equal to 2 into 5, so equal to 10 centimeter. Understood? How we find? So the distance is 20 centimeter we use. Okay, and so now we have a height of offset and the minimum offset, maximum offset is provided 5, and we have a total 5 centimeter distance. So for achieving 20 centimeter distance, offset is provided 20 by 5, it is 4 offset. Okay, so 4 offset will be provided. So now we calculate the number of offset provided in a foundation. Now what we do, that this depth, okay, that depth what we find first, it is correct or wrong, using that one equation, that the depth of a design depth is correct or not. So how we finalize or how we correct it, it is that using the width of footing and that width of wall and that distribution of load, we can find that this depth is correct or not. So first there is a equation, d minimum is equal to b minus t divided by 2n. Okay, you know width equal to 1 meter, then thickness of wall equal to 0.3 meter, 2 and n is what? So जो लोड ट्रांसफर करता है मीन्स दैट डिस्ट्रीब्यूट द लोड, इट इज ओके. सो इट इज 1/2 फॉर अ brick masonry. So after that calculating, you can find that. Okay, so 0.1 minus 0.3 divided by, okay, cancel it. So 1.3 minus 1 equal to 0.7 meter. So the minimum, so this is your minimum value 0.7, but what we do, we find that d equal to 1 meter. So our depth is correct compared to this equation. Okay, now we find thickness of concrete block. Okay, cement concrete block. Now we fix the amount A equal to 15 centimeter. Okay, that is this piece. Okay, the projection is given equal to 15 centimeter. Okay, so the 15 centimeter, now there is an equation to find thickness of concrete block is distance. Okay, equal to A under root 3q minus m. So you know projection is equal to 15 centimeter. This is your total load that is already we calculate, and m is equal to shape modulus of rupture. it is also given in a exam. So it is okay 520 kilonewton per meter square. So put the value A equal to 15 centimeter or a okay all dimension in 50 centimeter. So 0.15, then 3 into Q equal to 154.55, and then the modulus of 5 to the value 520. Okay, now calculate. Now we get that value in centimeter. So we didn't convert into meter, just put a value in a centimeter. Okay, so the value is, we find it is also in a centimeter. Okay, so after the calculating the equation, we get 14.16 centimeter. Okay, if you put here in meter, so the answer is in a meter. If you put in a centimeter, so value is given in answer in centimeter. Okay, so we just put a 15 centimeter, so answer is 14.15 centimeter. Okay, so this is the block, means base, height of the base. Okay, so this is the footing 15 centimeter, assume that is equal to 15 centimeter. So here it is your 15 centimeter base plate, and above that the projection is then happen, and then your wall is constructed. Okay, now what we do next, to draw a figure. Okay, so for drawing figure I have already prepared a sketch. Okay, so you know that this is your 30 centimeter thick wall. Okay, now the total width is equal to 100 centimeter, or you put a 1 meter as you wish. Okay, now the total depth of foundation, this is your ground level. Okay, this is a ground level GL. So from here to here, this is your depth, means 1 meter, or you will write 100 centimeter. Okay, so now what do you do first? So this is your CC block, CC plate. Okay, so height of this, it is 15 centimeter. Okay, it is 100 centimeter, and A, this is your A equal to also 15 centimeter. Okay, let we give a space to or given projection. Okay, this value is A. Now the projection, so you know the minimum offset is provided 5 centimeter. Okay, and the height, okay, it is 10 centimeter to each projection. Understood? And this is your wall thickness, it is 30 centimeter. And now the other remaining value, okay, from here, so how we calculate that? 15 centimeter, okay, plus 10, it is 15 plus 40, okay, 40 plus 15 is 55 watt. Okay,